Hi, I'm Julian Murray, and I'm going to talk about my research into Canadian baseflow trends and their climate predictors. First, I'll briefly define baseflow. Baseflow is the portion of streamflow which is provided by groundwater. It's an important indicator of groundwater availability and generally is the primary source of water for streams, especially in times of drought. It's a vital stabilizer of stream temperatures and supports ecological habitats. And it's difficult to measure directly. It's usually measured through tracer tests, but these kind of tests are not feasible at continental scales. Despite the importance of baseflow, information about how and why baseflow is changing across Canada is sparse. To help mitigate the effects of climate change and secure water resources in the future, we need to understand how baseflow is changing throughout the Canadian waterways. In this work, long-term monthly changes in baseflow are studied on a national scale and related to climate parameters. The results of this work will help identify which streams are deteriorating, which climatic parameters are involved, and what impacts it may have on local groundwater resources. I used streamflow data spanning 30 years, from 1989 to 2019, gathered from 1,275 hydrometer stations facilitated by the Water Survey of Canada. I separated baseflow from the streamflow time series using the digital filter technique first defined by Lin and Hollick. I then established monotonic trends in the baseflow data using the Mann-Kendall trend test. Finally, I related historical baseflow to climate parameters using GAMLIS. GAMLIS is a modern distribution-based approach to regression. The three climate parameters I looked at were precipitation, temperature, and antecedent wetness, which is the summation of the previous 3 months' precipitation. The climate parameters were averaged over the watershed basin to be related to the streamflow. Results varied by region and calendar month. Our focus today is Southern Ontario, so I've highlighted trends in this region. First, I'll look at January, which is representative of other winter results. Here we see increased baseflow trends in the eastern part of the province, south of Sudbury. The three climate parameters generally show positive correlations in the same areas, illustrating the impact of warming and increased precipitation. Antecedent wetness has the widest impact. I'd like to note that only locations that had sufficient streamflow and/or climate data available are indicated by colored dots in these figures. Long-term trends may exist in blank areas, but we would need further data gathering to prove that. Now I'll look at the results of July, which for Ontario is representative of May to December. Baseflow trends drop off after the spring thaw, only remaining concentrated around the Greater Toronto-Hamilton area. Antecedent wetness is once again a good predictor for changes in baseflow seen here, which is to be expected as it can take time for water to travel through the subsurface and discharge into a surface reservoir. I conclude that significant seasonal trends can be observed in many regions in Canada. Most trends are increasing, but there are notable regions with significant decreasing trends, such as the Southwest. Antecedent wetness is the primary climatic driver of baseflow trends, and warming is causing mobilization of water earlier in the year. The results of this work can identify what streams may be becoming intermittent and what groundwater resources may be declining. The relationship with climatic indicators can help determine the cause of changing baseflow, which can contribute to the development of mitigation strategies. Feel free to contact me for more information.